All right, so our goal today is pretty much displacement versus time. And you'll notice that there's a title, Kinematics. So what is that? Well, at least for us, you started off with biology your freshman year, and that's pretty much what is life. You try to explain everything about it, from all the way from properties of water to all the way to how ecology works. So life kind of based on that needs water to survive. Then you have your cells, then you have your organism, and then eventually ecosystems. And you understand everything in between there. Chemistry kind of goes into more detail where you're focusing on the chemical reactions itself, so properties of atoms, and then explaining how those atoms interact with each other through bonds, chemical reactions, etc. Physics, on the other hand, is kind of a combination of both. Like kind of chemistry explains how the microscopic parts of biology works. Well, physics talks about everything, from our sun, our universe, our galaxy, all the way down to atoms. And physics is usually broken down into three main parts, at least for us. You're going to have mechanics, which is what we're doing right now. Then you have waves, sound and light, and then you have electromagnetism. So for the first semester, we're going to focus on mechanics, and the first one is the study of motion. And the study of motion is kinematics. And today we want to focus on displacement versus time. It's one way of explaining how certain things work. So what I'd like you to do is to watch this video. It's really cool. It's a recent launch from SpaceX. You can fast forward it. I think it's an hour and a half. I don't need you to watch an hour and a half of it. But just fast forward to 1440, and that's where the launch is. I think that's where T-10 is. Watch it for about a minute would be enough, maybe two, just because it's interesting. And then fast forward to 2330, and that's when one of the booster rockets comes back down. They're both really cool. After you watch it, what I like you to do is think about what kind of things what words would you use to explain it? What kind of words would you use to explain it as it goes up? What kind of words would you explain it as it goes back down? So pause, click on the link, and watch it. Or Google it. I'll post it on the web. And then I have two other videos that are pretty cool as well. So you could watch those as well. But just always think, what kind of words can you think about that could describe these things? Okay, so push pause. All right, so hopefully you push pause and you came up with a couple of ideas. So how would you explain it? I used a couple of words myself. You have up. Hopefully you use words like going up, it was going faster up, it was coming slower down. Things are words that we want to use. Now there's more specific words that we want to focus on when it comes to physics, at least the first week. And these are the words that we have. We have displacement, time, velocity, and acceleration. So we want to make sure we use the right words. And I kind of want to define these for you. So displacement is a little bit different than distance. Distance is just a amount of thing, but displacement is x final minus x initial. So what does that mean? That means where I ended up minus my first one. So it depends on where you start. So I don't have to start at the origin. I don't have to start at 0. I could start at 10. So let's say I started at 10 meters. I could walk another 90, so that's 100. So then it will be 100 meters minus 10, which will give me a displacement of 90 meters. So you could do stuff like that. And so just remember, displacement is xf minus xi. X stands for your position. All right. Time is just amount of time. So it's just t f minus ti. Then you have velocity. One more thing about, tf minus ti, but this is always the absolute value. You can't have a negative time. Velocity is how fast you're going. And I'm going to come back to it because it's not a perfect explanation. Fast you are going. Let me just erase that part. And acceleration we'll eventually get to, so I kind of want to save that off for later. these are kind of different because you have something called scalars and vectors. So that's my next slide. So what is a vector? What is a scalar? They're a little bit different here and there. Okay, so scalar is probably what you might be more used to. So this is just one dimension. So speed, distance, time, these are all scalars. So that means there's no, I guess the easy way to explain it in math is there's no plus or minus. Well, vector, you have both a magnitude and direction. So here, these are all magnitudes. Speed, it's amount of speed. So in your car, when you're going forward, you're 10 miles per hour. When you're going backwards, you still say 10 miles per hour. Your car doesn't tell you negative. It just goes, it's like 0 all the way to its max. But when you're going backwards, it's still reading you off the same one. Even though you're going backwards, the speed that it tells you is a scalar because it's only a magnitude. Distance, same thing. How far did you travel? I traveled 10 miles. North, south, east, west is still 10 miles. So that 10 part is a scalar. Time is always a scalar. You know, it will be nice to go back in time, but most of us only think of time as forward. Vector, though, you need both. So displacement, if I could spell, displacement, velocity. Let's see, what else do we have? Acceleration, but we'll just pick with these two for us. So displacement is not only is distance, but it also has direction. So for our class, it's going to be positive or negative. North, south, east, west is another one. Velocity, same thing. It's speed plus direction. So you could have positive speed, negative speed. Those are your things. Okay? Now if we go back to our previous slide, displacement is x. So this could be above or below the x-axis, right? You could end up above, below, left, or right. Time is only, so this one's a vector, this one's a scalar, this one's a vector, and then this one eventually we'll get to is also a vector. So we have vector, scalar, vector, vector. Can't have negative time. Okay. What I'd like you to do is to look at that video, and what I like us to do is describe it more accurately. How would you reproduce that, or how can you tell somebody more accurately? So instead of something going, the rocket's going up, I like you to specifically tell me how it's going up. Think of the different measurements that we could do. We could do displacement, we could do time, we could do velocity, we could do acceleration. So I like you to watch that video. They do have things on the bottom left corner that kind of gives you hints to the data that you can have. The title of my thing is displacement versus time. So what I like you to do is go to it. I like you to pick out data parts from it. So this will be your time. And I like you to plot time versus displacement. So what I like you to do is, these are in kilometers, at least that, I believe that's what it says. Okay, I like you to go all the way to 2.0 kilometers, so it's not that far. So just watch it click, watch it click. Eventually it's going to get much faster. Do your best. If the times are getting too small and too difficult, then make it a little bit bigger. But let's just do a couple. I don't want to go too crazy with it. I think up to 10 is pretty good, but we'll just go up to 2. The time here is going to get really weird. So find the times for that, and what I like you to do is create a graph. And that is it for today. What I like you to do is to graph this data points, and then what you could do is, remember, when I want you to graph, this will be T and this will be D. Okay. So graph it. You could either do it on a graph paper or you could do it on Excel or Google Sheets. It doesn't really matter to me. And I want us to discuss it on Wednesday and then Thursday. Okay? Or the next times we meet. So either Thursday or Friday. All right. Thank you guys, and I'll see you next time.